Hi all. Here we detailedly explained about deadlock concept. In this, there should be two resources. Resource one is assigned to process one. That same resources needed by process two means it should be waiting for state. So once the assigned resource one is to process one means that's in at that time. Similarly, process 2 can assign process 2 can need for resource 2 means it is assigned that resource 2 is assigned to process 2. At the same time, process 1 also required resource 2 means it is waiting for. It is a circular state for every process waiting for various types of resources. So deadlocks are characterized by a set of necessary conditions that must hold simultaneously for a deadlock to occur. First, mutual exclusion. Resources cannot be shared simultaneously by multiple processes, requiring exclusive access to prevent data corruption. Second, hold and wait. Processes hold allocated resources while waiting for additional resources, creating potential resource contention and deadlock scenarios. No preemption. Resources cannot be forcibly taken from processes, leading to resource holding or deadlock risk. Then last, circular wait. Process chains form circular dependencies where each process waits for a resource held by another process in the chain, causing deadlock. What are all the methods for handling deadlock? For overcome this deadlock issue, we can find out the various types of methods. So that methods are deadlock prevention, deadlock avoidance, deadlock reduction, recovery from deadlock. So in this method, first we have seen about deadlock prevention. Prevention strategies aim to break one or more necessary conditions to eliminate deadlock occurrence. Techniques include resource allocation strategies such as ensuring resource hierarchy, avoiding circular wait, and using priority based resource allocation. Deadlock avoidance. Avoidance techniques use algorithms to dynamically allocate resource based on safe states, ensuring that processes can progress without encountering deadlock. The Banker's algorithm is a classical example of a deadlock avoidance technique. Deadlock reduction. Deadlock reduction algorithms periodically check for deadlocks by analyzing resource allocation graphs or using Banker's algorithm. If a deadlock is detected, corrective actions such as resource preemption or process termination are taken to resolve the deadlock. Recovery from deadlock. Recovery strategies involve restarting processes, rolling back transactions, or releasing resources to resolve deadlocks and restore system functionality, minimizing downtime and maintaining system stability. So, next topic, memory management. Background of the memory management is a critical function of operating systems that involve efficient allocation and utilization of memory resources. It ensures that processes have access to the required memory for execution and minimizes fragmentations. So, swapping is a memory management technique where processes or parts of processes are temporarily moved between main memory and secondary memory. It helps free up space in RAM by transferring less frequently used processes to secondary storage, allowing more important processes to run in main memory. So this is the swapping diagram. Swapping is essential for managing memory contention and optimizing overall system performance. In this swapping techniques, swapping is generally talked about between process between the main memory and secondary memory. Like we have already seen about what are the things which is presented in the main memory and what are the things presented in the secondary memory. In main memory, the operating system is built on the top of the main memory. Under this, there should be some space for user space. In that space only we can be swap in and swap out the process between this user space and the secondary memory space. So thank you.